Welcome back. We are going to start with the AC current. That's a very nice area, great to deal with. So the AC current, basically AC is the alternating. The meaning, the current direction keep changing. That is the meaning of alternating. The current direction keep changing. If it is a DC circuit like this, if you connect a resistance and the DC circuit, the current keep flowing in one direction. For example, if it is clockwise, it is clockwise always. But here, alternating means the current going through one direction. For example, if it is clockwise, and then it is reverse, anti-clockwise. So clockwise, anti-clockwise. So that is the meaning of alternating. So the idea of AC again is alternating the current when you have a AC power supply connected with a resistance or the capacitance, inductor, and other components. So that is the idea of AC current. So we are going to look at a resistor in an AC circuit. Now, one important thing. Now, it is not a simple idea in the calculations. So normally, if it is DC current, we can just calculate V equals Ri, simply put the values, then we continue with the calculation. However, in AC circuits, it is not that simple. So there is a formula. I just put this formula at the beginning. We are going to discuss that in details later. So VR, that is the voltage across the resistor, for example, if that is the circuit, AC power supply, current the passing through R. So formula for the voltage across the resistor, VR equal V maximum. There is a maximum voltage in the circuit. We are going to discuss that later. Sine omega t. That is the important thing. That is because AC voltage acting as a sine function. If you are familiar with the mathematics, that is a sine function. So that is a very basic formula. VR equals, that is for the voltage, V maximum sine omega 2. If you can just remember this formula, that is useful later. Now we are going to look at this resistor in an AC circuit. So we have the power supply, resistance, current is passing through the resistor and keep changing. And the voltage also same thing. Now the first thing is, because that's an angle involved, sine, that is the angle, that's angle involved. Therefore, when we are looking at the current and the voltage, that is voltage axis, we can put the current also. That is a phasor. If you are familiar with the phasor, that indicates the direction of the voltage. That means it keeps changing and it's passing through a circuit, and then that is called the phasor diagram, phasor circle, and that is the phasor that represents the direction as well as the quantity of the voltage with the time. So when you put the switch on here, the voltage keep the flowing, and also at the same time it keep changing the direction. So we can represent that, or we can show it with the phasor. So the phasor keep going with different angles. That's half a cycle, that's 180, 270, and completing one cycle, 360. So that is 90, 180, 270, and 360. So we can put a graph, because that is a sine curve. So VR here is a sine function. Okay. Now normally the sine curves are very straightforward graph. You are familiar with this. Okay. You learn in year 12 also. So if the phasor is moving like that, the graph is moving like that. That is 90 degrees. The phasor is coming here, then going down. That is 180. The phasor is here now, and then it is reverse. After 180, you can see 180 direction changes. So it's going down. So the phasor is going here. We are here now, 270, then coming back to the same place, completing one cycle, that is 360. And then after that, it continues like that. So that is the graph for the voltage across a resistor in AC circuit. So the voltage time graph is like that. So we are familiar with the phasor. Now always you need to have a phasor diagram. Then it's easier. It's not compulsory, but it's easy to follow the graph. So we have the the graphs. So we just discussed VR equals V maximum sign. We can write the same thing for IR. That means the current through the resistor equals I maximum sine omega t. That part is the same. Sine part because it's the same. So that is the sine curve, smaller one, shorter one. That is the sine curve. And the bigger one is the voltage curve. All right. Okay, now the one important thing. In the phasor diagram, voltage and the current start at 0 and move in the anti-clockwise direction. So that is what we are talking about here. Okay, direction. The voltage and the current in AC circuits are in phase. That means the voltage and the current in phase. You can see the graphs are moving. The quantities are different. Values are different, but they are moving with the same phase. That means the same angle. Angle is the same for both. So the current, the phasor is a little bit shorter because the value is smaller, maximum value. But in terms of the angle, both V and I are in phase. That means graphs are moving together. All right. Now we are going to the capacitor in an AC circuit. Capacitor is connected in series with the power supply. That is the power supply, that is the capacitor, that is the switch. So the idea is again AC, current, direction keep changing, okay, and the voltage direction also keep changing. Right, now for this one here, Ohm's law can be applied to the capacitor. That is normally V equals Ri or V equals IR, but for V, I is the same, but we don't use R, we use XC. That is called the, instead of resistance, the reactance. The word is reactance, XC. Same principle. That is a resistance actually, but we don't use the word resistance. Instead of resistance, we use the word reactance, also measured in ohms. No difference. So V equals IR. Same value, same ideas. Okay. Now, there are some important factors here. So the factors affecting the current or the reactance, that is XC, in an AC circuit. So what are the factors influencing the current and the reactance or the resistance across the capacitor? Right, there are some relationships. First one, I is directly proportional to the voltage. That means the voltage across the capacitor. I am referring to the capacitor now. So I and V are directly proportional. That is Ohm's law. V equals Ri. That means I is directly proportional. When the V increases, you have a bigger, larger current and vice versa. Then I again is directly proportional to the capacitance. Why? If the capacitance V is greater, that means it can hold more charge. That is the meaning of capacitance, amount of charge. So the charge is moving. Greater charge means greater current. That is direct proportion, right? I and C. Also, I is directly proportional to the frequency. That means the frequency is how fast the current direction changing in 1 second. How many turns, how many cycles it's making, just like one cycle here, then how many cycles are made in 1 second. That is the frequency. If the frequency is greater, that means current direction keep changing faster. That means more charges are flowing because the direction changing faster means more and more charges are flowing, therefore more current. So I is directly proportional to the frequency. F equals I over 1 over t, that is the period. They are inversely proportional. You should know this. Okay, three values, V, C, and F. So the current is directly proportional to all these three values: voltage, capacitance, and the frequency. Now we are going to rearrange this. We combine all these things. Therefore, I is proportional to V, C, and I. Bring them all together. Now we are going to substitute for V. Ohm's law, we apply that. V C equals I XC. Therefore, instead of V, we can write I and I C. Okay, V equals I XC. Now that is also the I cancel when as soon as you put V equals XIC, current on this side also, I on this side, they cancel out. Therefore 1 equals, we have XC here, it came C here, F here. K is the proportional. We change this proportion sign to equal sign. So that K is the proportion constant. The value is 2 pi in this case. Okay, so you have to remember that. That is from mathematical principles. So in this case, K is equals to 2 pi. Therefore, we rearrange this. Now, can you see this? C is here, F is here, I is not there. Out of these three factors, C and F are involved. I is not here because I cancel, and 2 pi. 1 over x equals, and now you can bring 1 xc to one this side, 1 over x equals 2 pi fc. So rearranging the same thing here, nothing new. Okay, right. Omega 2 pi f is omega 2 pi f. That's called the angular frequency. That is the definition. 2 pi f for one cycle. It's 1 over t actually. Then 1 over t equals f. So 2 pi f is omega. We can write 2 pi fc. That means omega c. 2 pi f is omega. Therefore omega c. So 1 over x equals omega c. Xc equals, just change the upside down, turn it upside down. Xc equals 1 omega c is going down, and that Xc is the reactance. So what are the factors affecting that Xc? Obviously, if you just put for omega here, that's 2 pi f, right? Omega is 2 pi f. So Xc depend on the frequency, and Xc also depend on the capacitor. Can you see this? How can you reduce the reactance or the resistance of the circuit? If you want to reduce this one, you need to increase F. We discussed that. F is increasing mean current direction changes faster, therefore bigger current. Current is bigger, larger, mean it has a less reactance or less resistance. C is bigger, Xc is smaller because 1 over. C is bigger. Why C is bigger? That means it can hold more charge. That means bigger current, right? Therefore, bigger current mean smaller resistance or the reactance in the circuit. All right? Okay, that is straightforward. We continue to the next slide. Right, that is a very simple slide. A smaller one, short one. We are going to define what is called the RMS, root mean square voltage or root mean square current. We call it VRMS, IRMS. In most of the cases, we are using this. The reason is, now this is a kind of root mean value. That means kind of average value. Mean is not really average, but it's close. Okay, because the reason is, in calculation, now you look at this graph, voltage or the current, it's a sine function. In calculation, what is the value that we are going to use? Different is changing with the time is changing, and therefore we have to select one particular value in calculation. So that is how we define RMS voltage and RMS current. Okay, so you have the peak value here, then we have the RMS values. That is a kind of a little bit smaller than the maximum value, but a little bit higher than the average value also. Right, now we define this. Okay, the average, the RMS voltage and the current. Instead of if it is a DC current, that's easy. Voltage is just one value, I is one value. They are all one value, so we can use these values in calculation. But here we can't do that. That is why we have RMS value. So IRMS equals I maximum divided by square root 2. Can you see, if it is an average value, we divide by 2, isn't it, to get the average current? No, it is smaller than 2. Therefore, IRMS is a little bit larger than the average current in this graph. So I maximum divided by square root. RMS, V voltage, same thing, V maximum here divided by square root 2. So that is the two definitions for I and V. I RMS, V RMS. Okay, so need to remember this. Therefore, how can you calculate the power? Now, even though we calculate, we put the AC circuit through a bulb is lighting up, power is produced, heat is produced. We have to calculate the heat or the power produced. So the formula for the power, that is VRMS IRMS. Normally power is VI, but here we have to use V and I RMS value. So that is how we do that. So if you put actually VRMS value is maximum over square root 2. Okay, I also maximum over square root 2. Therefore, V maximum times I maximum divided by 2. So that is also the power average. Okay, so that is how we calculate the power. So power equals V times I, that is RMS values. But if it is an average value, we have to divide this by 2. If you want the maximum power, then V maximum, I maximum. So that is very simple idea. Let's go to the next one. Okay.